right, so you should try drawing x squared plus 20x plus 100 before revealing the picture a little later in the slide, and pause and do that unless you want a little quick hint first. Okay, just to make sure, the hint is think about x squared plus 20x plus 100 as being the following. If you'd like, maybe this hint is helpful, maybe it's a little confusing. So you can rewrite 20x, of course, as 10x plus 10x, right? So you could think of the original expression as x squared plus 10x plus 10x plus 100. Now, try to draw a picture that has that. I hope that your picture looks like this, right? So you've got a stick of length x glued to a stick of length 10 going across. You've got a stick of length x glued to a stick of length 10 going vertically as well. And then the individual areas, x times x is x squared, and then 10 times x is 10x, and then 10 times x is 10x, and then 10 times 10 is 100. So you see all the pieces, x squared plus 10x plus 10x plus 100. That's just the geometrical way of writing out this x squared plus 10x plus 10x plus 100 in the algebra. Notice that the 20x in the original expression is really two separate rectangles whose areas are 10x each, right? 10x rectangle area, and then here's another rectangle with area 10x. There's two rectangles that look identical, just kind of rotated versions of each other. Both have area 10x, so when you combine those two together, you get 20x. Now, question, what belongs where the question mark is here in order to complete this square? Right? We don't have a complete square. So far, we've always had these four blue panels that all together create a completed square. We're missing a piece in the corner. Hope it makes sense that, well, this missing piece over here needs to have an area of, well, we got 3 and 3, so that question mark should be replaced with a little rectangle, technically a square, I guess, whose area is 9. Right? So if you see x squared plus 6x, and where did 6x come from? I'm thinking of 3x and 3x. So if you see x squared plus 6x, you ought to think of this more geometrically as x squared plus 3x, as we see in the picture, just those three pieces. And then if you added 9, that would create a square. Right? If you added 9 to x squared plus 3x, because what you have is not yet a square, if you add 9 to it, you would end up creating a square. So like this, right? So up here, these are two different pictures. They're very related, of course, but the second picture is bigger by 9. Right? So the first picture is not a completed square. It's just x squared plus 3x plus 3x. The picture at the bottom is a completed square. It's x squared plus 3x plus 3x plus 9. All right. I want you to apply this. Try answering the interactive question. So what should be added to x squared plus 16x to complete the square? Now, if you'd like to just go answer this, go for it. But if you'd like some hints, here are some things that might help out. Figure out what the second stick would be first. It's not 16, by the way, but it's related to 16. Just also, as a helpful hint, I hope, is just a moment ago, we thought of x squared plus 6x as x squared plus 3x, which makes it easier to spot the second stick. So similarly, try to think of x squared plus 16x as x squared plus something x plus something x. And I honestly think drawing a picture will be very helpful in answering this interactive question.